Welcome. This is Unit 1, Lesson 1 for Algebra 1, Translating Expressions and Equations. While watching this lesson, you should have the notes in front of you. If you do not have a copy, you can go onto our class website and print one off. Worst case scenario, have a piece of paper to write things down. As you're going through, if you need to pause the recording at any time to write something down or go get a drink of water or whatnot, you're more than welcome to do so. You can always rewind to repeat things that I've said and to listen again. All right, so by the end of today's lessons, you should be able to represent verbal expressions in situations algebraically and vice versa. Okay, so what does that mean? What are we doing today? All right, when we talk about verbal expressions, okay, we are talking about words. Now, keep in mind that math itself is a language. So what we are doing is we are going to take English words and put them into our math language. We are going to be writing them using math symbols. And when we say vice versa, sorry about that. And we're also going to be going in the other direction where you are seeing math symbols and then writing out the words that match them. Okay, so what we want to start off by doing is kind of brainstorming, taking a look at these symbols here, and these are some mathematical symbols, and we want to brainstorm some words that go with them. All right, so we're going to start in this first column right here. Okay, and we see that sign there, very common sign. You've seen it middle school, elementary school, everywhere. That is our addition sign. All right, so we want to think about some other words that mean to add. Okay, of course we have addition, we can say add. Some other words that we have, we could say sum. If we hear the sum, it's telling us we added two numbers together. We hear more or more than. Okay, we can put that word than after it, and we'll talk about the difference between those two later on in the lesson. Okay, of course, just the regular word add, like we said. All right, and those are pretty much your basic common addition words. There are some others we can brainstorm, but those are the main ones. All right, when we take a look at our next sign, our next symbol here, of course, this is our word for subtraction. We know we can put subtract in our list. And we want to think of some other words. So the opposite of more and more than would be less and less than. Once again, that word than does make a difference, especially for subtraction, so we'll talk more about that later. Okay, some other words that we can come up with. The word difference. When we say the difference between two numbers, it's asking us to subtract those two numbers. Okay, so a very common word for subtraction is difference. We could also, we've heard the words take away. Okay, could say take away from. Any word that really is telling you that the value is going down. Okay. All right, good. Our next symbol, our X right here, that's our multiplication symbol. All right, we've got a few words that also tell us to multiply. We can say times, very common one. Product. Okay, when we say product, that's when you multiply two numbers together. The product of x and 5. 5 times x, okay? Product. Now, another word I want to put up here, okay? We can hear the word 2 times. So if I say 2 times 5, you literally 2 times 5. We can also say twice. So when you see that word twice, it's saying 2 times. So it's kind of got its own fancy way of saying it. Anything bigger than 2 times, we would say 3 times, 4 times, 5 times a number, 6 times. So just keep in mind that word twice, what it means. Okay, our last one is our division symbol. Okay, we can say divided by. All right, another very common word for division is quotient. That's like the answer in division. So if I say the quotient of 10 and 2, really what I'm being asked to do is to do 10 divided by 2. Okay, so quotient is another common word. Once again, there are many other words we could add to our list, but here's what we're going to start with. Okay, these are ones that we're going to see a lot. And then, of course, as we come up with other things, we can always go back and add them on later. All right, so let's continue on. All right, so what we're going to first do is start with going from a verbal expression to algebraic symbols. So that's saying we're going to go from the words to the math symbol, the math language. All right, so we've got some steps we're going to follow. The first thing we want to do is just read the problem all the way through. Before you do anything, read it through. And then underline keywords. Like if you see the word product or sum, words that are telling us which operations to use. Those are keywords. We want to underline them. Okay? And then determine what symbols we should put in place of those keywords. And finally, go ahead and just write out your final answer with all of your symbols. So let's take these steps and let's actually try it. All right, so here's our first example, 2 more than a number. So I'm just reading it through, 2 more than a number. I want to underline keywords. All right, so first keyword I see is more than. Now, what operation do we know to be more than? The addition sign. Good. Okay, so I'm going to replace my other symbols too. 2, that's the symbol for 2 is our number 2. Now, when we're doing this, you're always going to have a number operation. You could have a couple, and we're going to have a letter or a variable. So when it says a number, I don't know what number is going here. So think back to your earlier days in math. How do we represent something that we call an unknown, something we do not know? We use a letter. Now, if they don't tell me specifically what letter to use, I can use any letter I want. If you want to write an E there, go right ahead. Okay, an X, a B, C, whatever. So now I replaced all of the words with symbols and I'm going to write my final answer. Here's one thing I have to be very careful of. It's not as big of a deal in addition, but it matters in subtraction, so we're going to apply the rules everywhere. That word than is kind of a trick word. When I see the word than, and it's only when this word appears, that word is telling me to take the two things on the opposite sides of my operation signs and flip them. So my final answer is not going to be 2 plus b, it's going to be b plus 2. The word than is telling me to flip or switch the order. So please be very careful, and we'll have plenty of examples where we'll see that or it won't be there and we don't need to do that. Okay, so if I had worded this problem 2 plus a number, oh, we should have added plus to our chart. We can go back and do that. But 2 plus a number, 2 more a number, that wouldn't sound right, but I wouldn't need to flip them around. But because this 2 more than, when I see that word than, whatever was in front of it, the 2, moves to the back. Whatever was behind it, the number, moves to the front. So b plus 2 is my answer. So here I went from words to math symbols. All right, let's take a look at our next example. 5 less than x. 5 less than x. Okay, so keywords, I see less than. Less than is telling me to use my subtraction. Okay, I see 5. And this time they tell me which letter, so I'm going to use the x. All right, now before we go and write out our final answer, notice keyword than. Super duper important in subtractions, telling me to flip that 5 in the x. So I want to write x minus 5. Okay, now last example. 7 times b less 6. 7 times b less 6. All right, so I see times telling me to multiply. Put a little x there for multiplication. And I see less telling me subtraction. Okay, so I've got 2 operations going on here. That's okay. All right, the more the merrier. So let's fill in the rest. I've got 7 times b less 6. All right, so everything has a symbol associated with it, whether it's an operation, a number, or a letter. I don't have the word than, so I don't need to worry about flipping anything around. I just need to write it out. So when I write it out, I have 7b minus 6. All right, please keep in mind, and hopefully you were taught this in middle school, that when you have a number being multiplied by a letter, you do not need a multiplication sign. You don't need an X, you don't need a dot, you do not need parentheses. Anytime you have a number in a letter or a letter in a letter, no multiplication symbol. The only time you would use one is for 2 or more numbers, just numbers. All right, in that case, we're in high school now, so we're going to move away from using the X and we'll use a dot or parentheses instead. All right, so let's do some more examples, okay? These are going to have a little bit more to them. So I see twice the sum of X and 4. Twice the sum of X and 4. Twice, keyword. Sum, keyword. Okay, twice is 2 times. All right, so for right now, I'm just going to put 2 in a little multiplication symbol for thinking purposes. When I write out my final answer, of course, we're not going to have that little X there, but we'll deal with that then. Sum is telling me to add. What am I adding? I'm adding X and 4. Okay, so the way this is written right now, I've got 2 times plus x4. So I know that that's not going to be my final answer. I'm never going to have 2 operations next to each other. So I want to make sure that I look at what's going on here. So it's 2 times, twice, 2 times, the sum of x and 4. All right, start back here with your sum of x and 4, x plus 4. Now what this is telling me is I want to do 2 times all of this. Okay, so I'm going to put this in parentheses. 2 times the sum of that. Okay, so whenever you have a 2 times first, you've got to be super careful, and we may have to use parentheses in there. Our next example, the quotient of y and a number 6. The quotient of y and a number 6. Underline keyword of quotient. Quotient's telling me to divide. Okay, I don't have any other operations in there, so I don't have to worry about anything tricky up there like in number 4. But quotient of y and a number 6. So it's telling me to divide these 2 things. So when you have a division like this, whatever comes first, in this case it's the y, that goes on the top. That's your numerator. 6 is my denominator. Of course, you could write it sideways like this too, 100% fine. Okay, just keep in mind that both of these are division. That's what a fraction is, it's division. Pardon me. So the quotient of y and a number 6. All right, now this one, the next one has quotient in also, but a little bit more involved, kind of like a number 4 type of thing. Whoops, moved the wrong thing. Sorry, guys. Oh, okay. So it says the quotient of 4 times f and the square of u. All right, this one's a little bit involved. So once again, the quotient of 4 times f and the square of u. Okay, so I see quotient for division times multiplication, square of u. Okay, we're going to come back to that, okay, because we need to obviously know what's going on down there. So what am I dividing? I'm dividing 2 things. I know it's going to be division, so let's go ahead and put our fraction bar. We've got 4, we've got an f, the square of u, okay? That means I'm doing u squared, okay? U squared. So the quotient of 4 times f and the square of u. That word and there is separating the division bar. Okay, whatever's coming before it is going on the top, and whatever's coming after that word and is going in your denominator. So I've got 4 times f, so 4f on the top, and my u squared down below. Okay, 4f on the top and u squared down below. So some of these are a little bit more tricky. You've got to be careful about how things are worded. Okay? All right. So now let's go the other direction. This way's a little bit easier, and there are multiple different answers for each one. You don't have to use the same exact words. So let's take a look. So our steps, we want to read the problem, always. Choose words to put in place of our math symbols. Be careful of any tricks. So if we have anything that deals with like parentheses, how we're wording that, so just be careful, and then write out your final answer. All right, so we've got 2 examples here. So let's take a look at our first one. Okay, read the problem. Read it using your words. 3 plus 5x minus this little symbol here, square root. Okay, you can get as fancy as you want. You can use as basic terms as you want. So I know I've got 3 plus 5 times x, the product of 5 and x. Okay, multiple different ways you can say it. You don't have to get super, super fancy. Minus, subtract, less, whatever, okay? Oh, minus, we forgot to add that to our list. How silly of us. All right, and that's the square root of b. Now notice, before we had a squared, that was a little 2 up top. Here it's a square root. Okay, the next one. I noticed I got a division problem and I've got things going on in between. So up top here, so let's take a look at this. This is one of those, I would say, tricky ones. On the top, I've got 8 times x. Oops. In my denominator, I have y plus 9. Okay, or the sum of y and 9, or 9 more than y. Many different ways you can word it. Okay, if these are tricky for you, start with the basics. You don't need to get super crazy here. Now, when I go and write this out, we don't want to just say, well, we could. Be careful on how you word it, okay? You could say 8 times x divided by y plus 9, but just be careful to make sure that when you're writing out, you're using commas when necessary. You could also say the quotient of, okay, because if I'm starting off with the quotient of, it's telling me the 2 things I'm dividing. The quotient of 8 times x and, because remember what came before the and was in our numerator, what comes after is in our denominator, y plus 9. Okay, or 8 times x divided by y plus 9. All right, good. Now, one last thing I want to go over with you very quickly. Okay, I know we don't have slides on it, but we do need to talk about equations. All of these were expressions. Okay, expressions are mathematical phrases without an equal sign, really. In an equation, we have an equal sign. All right, so let me write this example. The sum of x and 5 is 10. So now we're doing it the same exact way, guys. The only difference is we have a new component in here. When you see the word is, that is your key for equals. Okay, you could also have the words is equal to, but a lot of times we see is. So when I go through and I do this, I'm doing the same thing. Keyword is sum. I'm adding x. I'm adding 5. Is keyword equals the 10. So x plus 5 equals 10. The only difference in equations is we have an is or an equals to in the phrase. So that's just telling me I need my equals to sign and I need something on the other side. Okay, as we do practice in class, we will do a few of these as well. But just know that is the word for equals. All right, please bring any questions that you have with you back to class.